Does it started? What? Does it have started or not? Wait. Okay. Hello, 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 hello. Pretty nice. Hello. So we will be solving a question on lead code 87, which is a scramble string. Okay, let's try to solve this problem. Here we have, you can scramble a string to get string t using the following algorithm. Length of the string is 1, then stop. Okay, like grade, and grade is also a, okay, let's try to code it. Return solve s1 s2 solve string s2. What is the base condition? If both length are not equal, then I think return false. If both length is not equal, then obviously we can't scramble it. If both are equal, like s1 is equal to s2, return true. Like if the both is equal, then also we have to return true. If any of them is empty, then what? If any of them is empty, then what would happen? If s1 dot empty or s2 dot empty, if any of one of them is empty, then return. If both are empty, then doesn't matter. But if one is empty, like s1 is empty but s2 is not empty, then we can't do anything. So this is the best case. Now let us try to code our mm, like we have to break it into different intervals and swap it. We can swap it also, we can't swap it also. Two different things. Yeah. So for int, this is a MCM problem because mul what is MCM? That is multiplication chain. Like what is the MCM? MCM is matrix chain multiplication. Yeah. So we have to get I and j. What is the I and j? Just think of sorry, k is from what? K is from obviously is from 1, 1, k less equal j minus 1 obviously. What? J minus 1? N minus 1 obviously. What is n? Let's say n is our s1 dot length because we have already seen that if they are not same then we have already written false. Now if they are same then the length is also equal, so s1 dot length n minus 1 because if at the end you can't put it, so n minus 1 you can put it. Like for example, if you see great RGEAT, so 0 1 2 3 4, we can break it at like say GR, so 1 at 1, so at 2 I have broke I equals 2. Here also okay, for breaking points we have written. Now we will see if it is swapped. If it is swapped, then another ends, then we have to solve another thing, and if it is not solved, then we have to solve another thing. If it is, if wait, let's say, and we have to get what, whether they are scrambled or not. Yeah. So break it. Two possibilities. One is solve is1 dot substring from 0 to length is obviously k, comma is2 dot substring from 2. That is, I have to see the example again. G8. Okay. Um, more examples I have to see. Hmm. Okay, this example, let us say. This just come there, scrambled. And here it is scrambled here. R and G. Like after it is scrambled. Oh yeah. Like here if you see it's scrambled, we are solving the recursively, yeah. So it has come here. So the let's see this thing has come here. So 0 to this and 1 2 3 3 to length is k only. Length is obviously k there. Okay, so 1 2 3 4. Okay, and obviously n minus I obviously because 5 minus 2 is 3 and length is obviously k. If it is s- if it is swapped, also there is a possibility of not getting swapped, like great. So we have to see that also, and we have to return true or false whether they are swapped or not. Two possibilities, that is there's swapped and there is not swapped. This is if they are swapped. If they're not swapped, let's try to code that also. If they are not swapped, then we have to see other things. If they are not swapped, then mm, solve s1 dot, let's copy it and paste. If they are not swapped, then we are just moving to first and oh, wait. Yeah. And because it's the first thing we have done. The second thing is solve s1 substring I, and it is n minus k over. So because the size is 3. And the here would be it would be I or what? 0 I think to n minus 2 is 3. Mm-hmm. Yeah. Okay. Let's call it bool swap. Now let's do the same thing, but for not swapped. So s1 substring from like the 0 to k, size is k, it will be found obviously from 0, like great, for example, great and great. So first two things we have to see, and for that also 0 1 2 I2 n minus k, I2 n minus k obviously. These two things we have calculated. Now we have to return either of them is true. Either of them is true, we have to return that. Or else if it is not, then return false. If we do not have found the it is not like it is not scrambled. Either of them is scrambled. So it is a recursive way of solving. Okay, undeclared identifier I where is I? Okay, n minus I think k obviously. Mm-hmm. Just k, bro. Just k, not I. It's also k. What? Um, why it is showing error in this? I don't know. Let's see. But in both the cases, it is showing like it is pretty nice. Uh, mm, mm, if both is swapped, then we have they're swapped. Then S1 0 to minus k because 3 2 ठीक है and the second part it is k to n minus k and is bound in the 0 to minus k obviously. So this is both have the way scrambled then only. Yeah. um Solve S1 substring 0 to k. বন্ধু বন্ধু আমি যে গান করতে okay. So either of them is if return true. Swapped or not swapped, either of them is true, then it should return true. Okay, now it should work. Now we'll memorize it. Let's memorize it. We'll be using map, another map, which will store the string obviously, and pool. Let's say M, and we have to check if M of key not equal -1, then return M of key. Oh, sorry, sir. Not equals to M dot end, because if it is not found, if it is found, obviously if it is found, then where do we use it? What is the key? Let's say key is string key is equal to um, s1 plus some gap plus s2, and before returning we have to just simply add the key m of key is equal to like this. Let's see. Mm. Oh, sorry. I'm making lots of mistakes. M dot find let's see. It does solve. Next problem is egg dropping puzzle. Okay, in identical eggs, k floors, drop eggs. Like you have to drop eggs from floors in such a way we have to get the minimum ways. I'll be solving it by our DP, dynamic programming, by DP. It might work also, doesn't also work. Here, let's see. Floors. Let's see if this is the problem. Floors. 2x. Two identical x have to access building. You have access building with n floors leveled from 1 to n. You know that there exists a floor f where such that any x dropped at a floor higher than f will break, and any egg dropped at or below f will not break. Okay. In each move, you may take an unbroken egg and drop it from floor X. If the egg breaks, you can no longer use it. However, if the egg doesn't break, you may use it in future moves. Return the minimum number of ways that is needed to determine with certainty what is the value of f is. What is n? You are given two identical x. Okay, two identical x. Access to n buildings. Got it. So I have access to n buildings, and I have, yes. In DP problem we obviously use return solve, and we have two x, yeah? Okay, and we have n buildings, n floors in a building. Okay, int solve, let's say int egg for e and buildings for n. Let's try to write the recursive way of solving this. First of all, what is the recursion of this problem? Like, if the floor is, let's say, the x is obviously two identical x is there, so there's floor can be 1 if this is 1, or floor is 0. Then if the number of floors is 0, return f, or n number of floors. Why did I do this? Because let's say one floor is one way of solving, one way to get the, there is one way of dropping and getting the minimum number of moves, like the minimum number of moves, and we have to get the worst possible, I think so. 2x, yeah. Okay, so let's code it. Let's it's a base case. If n is equals to 1, that will one floor. Dropping it 1 times 0, also n doesn't matter. Egg is 0, let's say egg is not 0, egg is 2, obviously there is written. So now the base case is done, so we're gonna use int answer, let's say minimum, so we need int maximum. Got it? Then for int k from, I think, first floor to n floor, we have to just increase the floor. Let's say started from 1 floor and moved to the n floor. Okay, and we're dropping it. Okay, so int temp is equal to solve, let it solve our, if it, if you drop, let's say you drop a a egg from any floor, let us say a f floor, then it may break or it may not break. The two choices, it may break or it may not break. But yeah, we have two choices, so let's write the two choices. And if it breaks or it not break, okay, two choices, break, not break, and we have to get the maximum out of it because we need the worst case, and after that we have to get the minimum ways. So egg is obviously e minus 1 and n minus 1, because let's say, sorry, I think, yeah, k minus 1, because let's say you are in a kth index, kth floor, and you have dropped so k minus 1 is the, like, if it is not, if it has broken, so upper it will not work. If it is broken, then egg is minus 1 and the size is like is k, so k minus 1, and solve if it is not broken, then n minus k, because k is there. Let's go upper, we have to go upper, we have to get the max, so max of this both. Got it? Then we have to return or get the answer as the minimum. So minimum of temp and answer, which I have already written in max. Return answer. Might work. It should work. It should work. There is no possibility of not working. Let's see. TLE, because we haven't used the optimized way of solving this. Let's say DP int T. What is the constraints? What is the constraints? 1000. 1000. Okay, 1000. 1 1 if T of, no, this is only 2x 2 ah egg n, sorry, yeah, if n not equal -1, return T of e n, return T of, let's say, before answering, before putting the answer, we just do this thing in memorization, that we just store this and equals to -1, that is mem set. Obviously we have to just set it, mem set T -1 size of T. We have just made it -1 wholly, and we have written this thing that if it is not -1, that means it has already been solved. We just return that thing, and before returning we just save it in our matrix, so we can say. Let's see if it does work. What does it say? Stack Overflow. Okay. Mm-hmm. And 2x, let's say it, let's say n plus 1 we do now, so let's say 3, and the maximum, and if we get one thing, so mm, mm. One thing for sure, we have to do this thing also, because e is reducing also, yeah. So if e is 1, egg is 1, egg 0, so if egg is 1, return n, because one by one we have to just do this. One by one, you have to. Worst case. I told you. I told you that this is gonna work. I see what is the most optimized one solutions that is been big of one time complexity. 2x. What is this? Bro, what is this? I don't know what it is. 2x. One line solution. Cursive iterative generic. Mm. Yeah, because one thing is changing. So one DDP we can use. Um, okay. 2x, yeah. Hmm. 2x. Mhm. So hope you like this video. Bye.